Our next quantity is momentum. So let us see what is momentum. Momentum is a quantity that depends on both the things, that is mass and also velocity. Consider an example here. This is a shot put ball which moves in this direction with a velocity of 1000 meter per second. It has a mass of 1 kg. And this is your car, which moves with the speed of only 1 meter per second, but it has a mass of 1000 kg. Here momentum is represented as P, which is nothing but a product of mass and velocity both. You must have heard this word in cricket commentary, that momentum of a ball. This word you must have come across in a cricket commentary because the momentum or the direction of a ball which used to change when the batsman hit it, and commentators usually use this word. So now I can say that momentum of my shot put ball is mass times its velocity, that is m into v. Right here it will be 1000 kilogram meter per second, and momentum of my car is also equals to 1000 kilogram meter per second. So here momentum of both a spherical ball and car are same, though car has more mass compared to spherical ball and ball has more velocity compared to a car, but the product of both mass and velocity are same for both. So momentum for both will be same. So momentum is something that depends on both mass and velocity. So here we can say that for dimensional formula of momentum, it will be m1 for mass and l1 e raised to minus 1 for velocity. So here your formula will be m1 l1 e raised to minus 1. Next quantity. So our next quantity is force. Yeah, it is a very familiar term which we use in our daily life. So according to a law of conservation of linear momentum and Newton Uncle's second law, we can say that force, the definition of force is given as with reference to momentum. We know that whenever a bowler throws a ball, for example, this is a ball, and when it throws to the batsman, and whenever a batsman hits a ball, its momentum gets changed. So change in momentum is only because of the force of a bat. That's what Newton Uncle said in his second law, that is a change in momentum with respect to time. Change in momentum with change in time is because of external force F. Then external force is something which can be defined as change in momentum per unit time. Now let us break this formula in one more expression. What is momentum? We had seen previously force F is equals to change in momentum P is nothing but mass times velocity divided by delta T. Now here mass is constant, take it outside, take change in velocity upon change in time, and we know that change in velocity with respect to time is nothing but acceleration. So force has many formulas. Among them the basic formulas are mass into acceleration and change in momentum with change in time. This both formulas represents Newton's second law of motion. And from this we can derive dimensional formula of force, that is what is dimensional formula of mass, that is m1, and dimensional formula of acceleration, that is l1 e to the power minus 2, which is given as m1 l1 t raised to minus 2. So this is dimensional formula of force, which you should remember without derivation, because force is a very common dimensional formula which we're gonna use in many other quantities. So force and energy, these both dimensional formulas you must remember. So our next formula will be of energy or work that we will see. And here one more thing I would like to say you is unit of force. Unit of force is unit of mass is kilogram, and unit of acceleration is meter per second square. So it is kilogram meter per second square, which is also known as Newton, in memory of our Newton uncle. So next quantity will be energy. Let us see it. Now our next quantity is energy or work done. Yes, they both are same because energy supplied will result into the work done. So they both have same dimensional formulas. Now consider this box, and to move this box or to displace this box for some displacement d, we have to apply force, obviously F, right? So force applied for displacement of any object is referred to as energy. So energy is force times displacement, and that is the same formula for work done. So we had seen dimensional formula of force, that is m1 L1 e raised to minus 2. Add one more displacement, that is add one more L1 to our force, we'll be getting m1 L2 t to the power minus 2. This is a dimensional formula of energy or work done, and its unit is Newton into meter, because unit of force is in Newton, unit of displacement is in meter. So its unit is Newton meter, or it can also be called joule, J, or it can be written as JW, joule. You must have understood, and unit for both work done and energy utilized, or we can say energy and work, is same, that is joule. Now let us see our next quantity. So our next quantity is power. You must have seen a package of any electrical instrument. You can see that there is always power rating in watt. In a unit, watt is given on a package. You know what does that mean? It means this bulb will consume 60 joule energy in 1 second. This bulb will consume 60 joule energy in 1 second. That means its power is 60 watt. So power is nothing but energy consumed upon time, and this is a formula for power. Now for dimensional formula, what is dimensional formula of energy? We had seen just now, that is m1 L2 to the power minus 2 divided by for time, it is t, that is equals to m1 L2 t to the power minus 3. It is a dimensional formula of power, and unit of power is watt. Either it can be written in capital W or small w. Its SI unit can also be given as joule per second. What is, because energy is given in joule, time is given in second, so its unit is also given as joule per second. Okay, so now let us see our next quantity. Hey friends, so our next quantity is pressure. For pressure, consider these two palms, and on one palm I am putting a book, and on this, if I am applying a pressure using a pointed pencil, what will happen? My hand will not experience much force, because most of the force will be distributed due to this greater area, right? So application of force, on this area will decide how much pressure will be transferred to my hand. So I'll feel less pressure because of a book in between, because book increase the area. And on this hand, if I'll put pencil directly without any book, then I'll feel tremendous pressure, because here you can see that area is very less. Where my pencil hits, that area is very less, and here area is more. So if I'm applying same force here but to the lesser area, where here the area is more, to the lesser area, then my pressure will increase. That means I can say that pressure is such a quantity that depends on two things. Pressure depends on two things. One is force, another is area. Why I had written area in denominator? Because anything in denominator, if increase, means if I increase area, my pressure is decreasing. So I can say that my pressure is inversely proportional to area. That's why area should be in denominator, it should not be in multiplication. And we can say that for dimensional formula, the dimensional formula force is m1 l1 e raised to minus 2 divided by dimensional formula of area, that is L squared, and your answer will be m1 L minus 1 e to the power minus 2. So that is a dimensional formula of pressure. Okay, its unit is Newton per meter square, and it can also be called Pascal. Hope you have got this unit. Let us see our next unit. So next quantity is time period. Time period is the simplest quantity which has a dimensional formula of t1. It is very simple. It is represented as capital T. Its dimensional formula is t1, but it is very different compared to a normal time, because time period is something time to complete one wave, time to complete one circle, we can say time to complete one oscillation of a pendulum. For a single oscillation, we can say the time required for a single oscillation is called the time period. So it is different compared to our normal time, right? Hence the word period is used instead of only time. So it's a simple, its dimensional formula is m0 L0. I don't have any other dimensions, just dimension of time. Its unit is second. So let us move on to our second unit, next unit, that is frequency. Frequency is something like how frequently things happen. For example, the frequency of my heartbeat is 76 heartbeats per minute. Right? So I can say that for my heartbeat, the frequency of my heartbeat is 76 beats per 1 minute. Right. Frequency of my pendulum is 2 oscillations. Sorry, 1 oscillation per 2 seconds. So something how frequently it happens. If you know the source of AC supply, that is electricity boards that you have, also comes in terms of waves. Right? Electricity comes in terms of wave. So frequency of this wave is 50 cycles per second. 50 cycles per 1 second. So any number, frequency f is equals to any number of oscillations per unit time. Our frequency is also defined as inverse of time period, 1 by time, and its unit is 1 upon second, that is second inverse. Its unit is second inverse, which is also called hertz. And its dimensional formula will be m0 l0 e to the power minus 1. Hope you have got all the points and all the units or all the physical quantities, and you understood each one of them clearly. And now the remaining I'll be covering in our next video. Thank you.